Hi, I'm Hesh. I'm the product manager at Ørgreen Optics. I'm coming here today from Copenhagen, Denmark to talk to you about our quantum frame. You should probably recognize that my voice does not sound Danish. That's because I'm an American, but been living here and working with the Ørgreen team since 2013. We're going to talk about how the history of the frame came about and where the design concept came from. So the goal from our head designer, Tobias Vandrup, who's also one of the founders of Ørgreen, was to develop a unique frame that had a screwless hinge concept. There's many different types of screwless hinges on the market, but we wanted to come up with something different, with a different way of thinking about the product and the frame. The hinge concept that Tobias had created required a cavity on the inside of the front frame that could not be done through normal manufacturing techniques. So that's how we linked up with the world's premier 3D printing company, who is working with the aerospace industry, the Formula One industry, and also the medical industry due to their high level of technology, materials, and creativity. So once we started working with the 3D company, we found many additional benefits of working with the 3D printed material known as polyamide. The lightness, the durability, the robustness, the flexibility and memory of the frame all bring superior benefits that worked perfectly with the quantum concept. So as we were new to the 3D printed world for us at Ørgreen, we had to really get involved to understand how the 3D printed process worked. A quick little background of how laser sintering, also known as 3D printing, works is the selective laser sintering starts with a print chamber where you have this polyamide powder. A laser beam comes down and directs a focused beam on the shape that you want to create and goes layer by layer sintering or bonding together that polyamide powder. The polyamide powder is very fine, and through the process of bonding layer by layer the polyamide, out of that grows the frame. One of the benefits of laser sintering is that the material only bonds together the shape of the frame needed. All of the additional powder is not wasted and can be reclaimed and recycled and used in other 3D printing industries. So it has a very good sustainable benefit. After the frame has been printed and the surface has been treated and smoothed, it is now ready for the coloring process. The frames are colored through a dyeing process in which the frames are dipped in a color liquid, which allows the liquid color to penetrate into the frame material, which gives a nice, solid, uniform coloration to the frame. When you hold a quantum frame in your hand, the first thing you notice is how light it is. That lightness translates directly into comfort and fit on the person's face as they're wearing a frame. The adjustability of the quantum frame is just as easy. The polyamide material is a memory material, but with heating similar to as you would do with an acetate material, you can adjust and bend the front shape to custom fit to the wearer's needs. Part of the concept of the quantum frame was to incorporate the material that we use in our normal titanium frames into the quantum designs. And to do that, Tobias used the beta titanium material that we use on our existing frames. We also wanted to bring in the comfort and customization fitting of metal nose pad arms and silicone nose pads that we use on our titanium frames. That allows a custom fitting for the nose onto the wearer's face. These design features are what we call functional minimalism, and that is typical of Danish design, which is a core value of Ørgreen. Each frame is assembled here by our team in Copenhagen, which allows us to have 100% quality control to ensure the fit, details, and quality of every frame that leaves our office. We're constantly pushing the limits of what our 3D printing partner is able to do on the finishing and coloring, but in the end we feel that the product that we have on the market is superior to others that are out there, and we're quite proud of what we have.